So welcome everyone to the fourth and last webinar of the SLB webinar series, which will explore the OFM reservoir surveillance and forecasting by engineer Taiba Majid and engineer Fatma Nazem. This is Muhammad Subhi and I will be the moderator for this webinar. As mentioned, we have two speakers today. First speaker is engineer Taiba, a petroleum engineering graduate from University of Baghdad in 2016. Petroleum engineering graduate and production engineering team lead in Iraq with SLB for more than 7 years of experience in oil and gas industry, production engineering specifically, starting with the production log interpretation, like SLB to log, Kappa Emirate, and to work over operations simulation for real-time decision making. Also, we have engineer Fatma Nazem. She is a digital production engineer with SLB and with the petroleum engineering background, supporting all digital production engineering for all OFM and PipeSM users in Iraq. We would like to thank Engineer Taiba and Engineer Fatma for being here today, and the mic is now yours. Thank you.
Thank you, Mohammed. Thank you so much. Hi, everyone. Hello, good evening. I want to thank you for attending and for your time for sure. I'm Fatma. As Mohammed said, I'm a petroleum engineer and I'm working in SLB right now as a production engineer. Currently, I'm supporting OFM and PipeSim and the other software that called Avoset. Please let me share my screen, just a minute. Can you please confirm if you can see my screen?
Yes, it's great.
Okay.
Yes, we can see you.
Yeah, okay, that's great. So let's start. Our presentation for today going to be about OFM, Oil Field Manager. Specifically, the topic is about the reservoir surveillance and forecasting. Our agenda for today, as you can see here, we're gonna have an overview about OFM, and also I'm gonna take you in a walkthrough an OFM user interface. We're gonna talk a little about the latest features that was added in OFM 2023 version, and a brief review of decline curve analysis, the theory behind it, and why it's used. And of course, our main topic for tonight, which is forecasting. We're gonna talk about forecasting in OFM. And we're gonna move to the demo, the live demo in OFM, and the closing will be with the Q&A. So let's start with the question, what is OFM? In case this is the first time you are getting to know OFM, or Oil Field Manager. Simply, OFM is a very, very powerful tool used for surveillance, for analyzing. Just like it's widely used by professionals in oil and gas industry, because it provides you with an array of tools for managing, for analyzing, and also the most important thing, you can visualize these analysis in a variety of very ways. Like you have the chart, you have the plots, You have also the reports. So it is a market-leading software for prediction analysis. It also can do the forecasting, can be used for planning also. And there's a lot of features in OFM. The most important one is can be integrated with other tools, even if it was not SLB tool. Also, it can deal with different databases, such as SQL database. It can deal with Excel sheet, Access, Microsoft Access database. So it's very flexible tool. And here you're gonna see the OFM user interface. This is OFM. In order to get familiar with the terminology of OFM, we are having the legacy tools, and we are having the analysis, the new analysis dashboard. It's been added in the latest versions. If we're gonna talk about the legacy, here is the analyzing tools. You can see plot, forecast, report, grid, a lot of tools here. And these tools was developed and migrated to a new one place, which is the analysis dashboard. The first one you can see here. It's, the legacy tools are not removed. They are just kept here. And they are existed here in the dashboard. Also, we're going to talk about this once I open the software. You have the pans, the analysis shows, it will show you every single analysis you're going to open, and you can rename it and arrange it. Here you can see the filter where you can create your filters. The navigation that can show you the hierarchy of your project with the different levels, starting from completion, wellbore, zone, and so on. And here are the properties. I'm going to talk about the forecasting here. So let's start with answering the question, why forecasting? Why it's needed? So simply because one of the primary challenges of any organization is determining how much a product it has. This determination is not a simple task. There's a lot of complex complications in determining these products you have, the reserves. And because you will have technical limitations, you will have economic limitations. Why it's important to know your reserves? Simply, in each industry segment, they have specific needs to know the reserves of oil and gas. If we're gonna mention those, there are several stakeholders that who are concerned with knowing the oil and gas reserves, such as the companies and individuals. Also, oil and gas, the guys who are responsible for exploration, the banks that are responsible for investing in exploration, development phases of the oil and gas, the buyers and sellers of oil and gas properties, and also the guys who invest in this industry. The agencies and the taxation guys, also all of these guys or stakeholders will be in need to know their reserves. That's why we are using forecasting to know how much reserves you are having and what is the future performance of it, when it's gonna decline, like how long am I gonna leave my wells open for production, will it give me a value, will it give me a revenue? That's why we are using forecasting. In OFM, there's a lot of models or techniques that are used for forecasting. Here I'm gonna mention or focus only on these two, empirical and Vitkovich. Simply, empirical here is just a method that is based on equations, mathematical equations, which are, to be specific, Arp's equation. This one will use interpolation that will interpolate the already existing data and make their prediction based on your historical prediction data. The other one is Vitkovich, or we can call it the type curve. In this solution, there will be a set of type curves to represent typical performance of ideal, or we can call it conventional, with the finite radial reservoirs. The plotted or real data or real curve will be matched with one of these curves of Vitkovich. The ideal Vitkovich curves or type curve, it will be drawn a log analysis. It assumes that the rate decline after a period of the pseudo-steady state it will be dominated by a flat or constant rate when plotted against time on a log-to-log scale. Just to demonstrate it more, this is the decline curve here. And this is the flat period that Vitkovich mentioned. There is another thing that I have to mention is the other two methods, which is the one of this is the transient method. And in the transient, this will give us more information about, like, because it will be representing the early life or early effect of your pressure wave movement. So it will give us more information about the reservoir, such as the permeability, skin, the inner and outer boundary of the reservoir. But if you want to know your volume or reservoir volume, you will focus more on the dominated or boundary dominated flow. So these are two important things in forecasting to know your original oil in a place. So you may arise a question here why we are using the decline curve analysis theory. Simply because decline curve analysis techniques, these techniques are used to estimate the ultimate recovery, to forecast your prediction, also to calculate or find the deliverability rates, evaluating your historical data, and projecting them to give you the prediction of the future performance of your reservoir. And you determine your economic limits, your technical limits. And this will modeling these trends with an equation, because it's basically based on equation, mathematical equation. Then these equations will be used to project this trend of data to the limits, as I mentioned, the economic and technical limits. And the biggest advantage here of using the DCA or the decline curve analysis, because it's simple, you don't have to get your detailed reservoir data. You don't have to get your reservoir size, your reservoir shape in case if you don't have it. Because in decline curve analysis, all what is needed is to get a prediction data, stable and representative prediction data. And then this data will be used in these equations that I mentioned before to make these curves here. This is the data that I've been talking about. And OFM will just calculate it and make the forecasting based on several equations and models that's already embedded in OFM, and will give you the result. And here is the limit, the economic or technical limits. Here would be the historical data that you have. Here's the parameters. I'm going to mention all of this detail in the demo. Okay, so the mostly used technique of decline curve analysis techniques, which is ARPS. ARPS equation. ARPS created the foundational decline curve analysis by proposing the simple mathematical curve. There's three curves here in ARPS method. We have the exponential decline, where they have the p-value, which is constant here, is equal to 0, and this is the equation of the exponential decline. The second equation, which is the harmonic, in case of your p-value equals 1, and the third one is the generic hyperbolic decline, when the p-value is between 0 and 1, which is this. This is mostly used, the hyperbolic. The hyperbolic will be more generalized, and it will give you forecasting on the long term. On the opposite side, for the exponential, this will give you only for short-term data and short-term forecasting. Here are the three curves that are used in ARPS. So we mentioned p-value. What is p-value? P-value simply is an important parameter in decline analysis in OFM. P-value will be automatically calculated when you conduct the history matching. When you conduct your history matching, this will be visible in the properties pane. Once you open the forecasting, there will be a legend that will give you all of the results. And once you match your data, let me go back here. If you can see this green line here, once you make your forecast and just pick a stable period of data here, you will see the results in a legend in the older version of forecast, and you will see it here. This is the p-value I've been talking about here. It's equal to 1. That indicates the harmonic curve. So all it's needed is just to make your forecast, and then it will be automatically calculated. Also, you can there are more associations you can do. You can add details to your performance in case you want to determine, user determines the p-value between, let's say, for example, 0.2 to 0.4. We're gonna apply this in the demo also. In empirical decline solutions, there are more than just ARPS. ARPS is a conventional method. Also, we have the unconventional methods, such as Duong, power law, and the SEP, stretched exponential. Stretched, for example, let's start with the stretched exponential prediction decline. The advantage of this one is to get that we can get the final value of estimated ultimate recovery, the EOR. This is designed for the long period of a transient flow, atypical of unconventional reservoirs. And in case we're gonna talk about the Power law, PL, the Power law exponential, this method is used to predict the gas reservoirs in a low permeability conditions. This will be done by matching the early transient data, but it will not over predicting the reservoirs. And for Duang, which is we skipped it, the first one. This one was specially developed for shale and tight reservoirs with a micro or nano Darcy permeability. That's why we can see the ARPS is the mostly used method or technique. Okay, once we open OFM, there is two approaches to make your forecast or even any kind of another analysis, because as I mentioned, we have the new analysis dashboard that contains all of the tools in one place. which makes it easier. And also you can use the legacy tools here. The forecast here, you can see corresponds with the new one here, forecast in the new analysis dashboard. Also, once you open forecasting here in the legacy, you will have the scenario manager, the schedule. These three tools will be here and forecast tables. So it is kind of separated in the new analysis dashboard, but it's all in one place in the legacy. There is one note I want to mention in OFM. So you can see here, you may say that they are separated. No, the analysis dashboard, the new one, and the legacy, they are interconnected. What I mean by mentioning this is once you open or create an analysis here in the legacy tools, and then you're gonna open this analysis here, you're gonna see the effect. If you save it, you're gonna see it here. So they are interconnected between each other. They are not separate at all. This is the forecasting in the new analysis dashboard. When you open the forecast templates, this is the screen you're gonna face. You will have the templates. You have to create your template. You have to specify your phase. You're gonna have your prediction on a specific phase, which is oil, water, gas, or and the solution. If it was ARPS, if it was the SEPD or the BL, the power law. Here you will specify the variable, the oil rates, to what your variable is referencing, your oil cum variable also, the analysis, and the fit type also. If there's a lot of options here, you have the best fit, which is determined by OFM, or the other three equations in case we are choosing ARPS. As you remember, the exponential, harmonic, and hyperbolic. This if you work on your template. Also from this side, you can add the schedule, and all of these details we're going to talk about in the demo. Okay, forecasting. In decline curve analysis, we have the assumption, the advantages behind the decline curve analysis, and scalability. In case we're going to talk about the assumption. As mentioned, you can determine your future behavior of your well. How you can determine it? It's all will be based on the trend and matching your historical data, your prediction data should be representative data and stable. This, depending on this approach and the mathematical equations in OFM, you will know what is your performance in the future. And as mentioned, the advantage of using the decline curve analysis, you don't have to get your detailed reservoir data because it's independent of size and shape of the reservoir. The scalability. Sometimes a single curve may not be sufficient. What I mean by this, if you make a forecasting for your whole completions, if you group your completions and make a forecast, this may not be the same forecast when you do it well by well. So there's a scalability in this. Okay, let us move to the demo. Can you see the OFM window?
No, I think you will have to stop sharing and start sharing
Okay.
again, Fatma.
Yes, now it's clear.
Okay, thank you so much. Yeah, just a minute. So once you open your OFM project, this is what you are gonna face. The first thing gonna open is the base map here. They're gonna show you your wells. Sorry, I have a filter here. Let me clear the filter. We've been told that OFM is just like a little princess, so you have to deal carefully with OFM. One touch, one touch at a time. Um, Here, the analysis dashboard. This is the tools, analyzing tools. You got the line, bar chart. These are the charts. Scatter plot, mapping, reporting. Okay, hope it will not crash. Yeah. Forecasting, type well, PDF. This is a new addition to the analysis. Also, this is one of the new features in 2023. I'm gonna mention them in a few minutes. This is the template that I've been talking about in forecasting. Forecast manager that contains the report for forecasting and all of these other tools. And here's the legacy tools. The plot. The plot here is just the same, the line here. Forecasting. This will be separated to forecast and forecast templates. And reporting here corresponds with the reporting here. This is in Home tab. In the Setup tab, here you have the schema. This will contain the this will act like a backbone for the project. Contains your tables. Sorry, just a minute. Contains your table here. So here you can see the configuration of your project, the workspace, and then here the databases. The databases here with the home icon, this represents your home database. This is the main database. I said and mentioned earlier that OFM deals with a very different types of databases. You have the ODBC, you have a SQL database, you have Microsoft Access. All of these and other different types of database can be made as a home database. OFM deals with Excel sheet, the separate sheet, okay, but it cannot consider it as a database. So it's just additional database here. Here's your columns. Each table have to have the key column with the key icon. From here, you can show all your tables. And okay, this is your schema that shows you the configuration of your project. I'm not going to make any additions here. Also, you have here your associations, the data grid. This will contains the data, and you can write on it to add any additional data. But this one is very like you can't use it very widely. You can use your database, but this one just like it will be permanent. Once you write on data grid, it will be permanent. So you have to be careful dealing with the data grid. Here you can add your calculated variables because OFM may not contain all of the variables you will need in your work. So you can use this one to add a calculated variable. Just let me open it. Here you can go and tell OFM I want to add a new variable. Okay. Here you will have variables from this 3 dots. This is user, this is class of your variables here. These variables already exist in the project. I'm just showing you, I don't want to make any changes. And here's the system functions. We have just like Excel sheets. We have the ads, a lot of formulas here. You can find it and just use it freely. Blank spaces if you want to exclude it, and so on. And also here you can see OFM explains to you what each of these functions that already embedded in the system. It shows you here the explanation what it can do. It's just like a calculator here. So once you're done with your script of calculated variable, just tell it OK, and it will be added here. And then you can add your unit because it will be completely new with no units or something. Okay, so we are done with this. Here you can add or specify a new function that is not already exist in the project. Here we have the workspace manager. From here you can export and import data. For example, when you are working on base map and you have a notation that shows you, for example, a fracture. Let me go back here. As I mentioned, one touch at a time. So, or little princess here. I don't want it to crash. If you want to add a notation, a shapefile, you can import it from here. Import, export. And we have the property inspector. This can do a lot of things. Once you open it and then click on something or entity, and it will edit it. Okay, let's wait. Okay, I'm gonna try it on the map. It will be better. Okay. So this is one of our analysis, which is map. This will take its information, the background here. You can see it will be taken from the GIS map, so it's more realistic here. It's way better than the base map. This is different background you can use, different maps here. And because it deals with the Esri. Okay. Here you have your legend, where the green one, the green dot here, refers to oil producers. And here is the property inspector. You can open the property inspector. Okay, this is the edit. So let me open the property inspector again and let me click. Okay. This will modify or edit whatever thing you are clicking on in OFM. So once I click here on the wells, it will show me what I can change here, things that's related to this entity that I'm clicking on, this object, like the size, the split, overlap. Okay, I don't want to be overlapped here. Okay, look, it's changing now because I clicked on another object. It will show me the editor section. Because I clicked on the map, sorry, it will show me more details about the map, what I want to change in my map, like use longitude, latitude. If I choose no, okay. The GIS map is gone because it depends on longitude, latitude. So we're gonna go back. Scale legend here. Okay, I'm showing it. The XY. Okay, it's showing me the latitude, longitude here. Sorry. You can do a lot of things with the property inspector in any analysis you are doing. Okay, let me close it. Once you pick your variable, just click finish, and that's it. You got your analysis. Okay, let's go back. We were here in the setup. And the last thing we have is the view. In the view here, you can you can activate and deactivate a lot of things. The zoom map for the zoom and pan, for example. I don't want it, so let me inactivate it. Filters, analysis, these spans here, analysis, properties, and here you can find the filters. The filters contain three parts. The forecast contains the archive. If you have any filter and you want to archive it and save it, you can just archive it here and use it over and over again. And here is your filters. A lot of filters. the project filter. There's something I want to mention about the project filter here. Any filter you're gonna use in a session of OFM, once you close the session and open it again, the filter will be gone. But for the project filter, this one is permanent. So anytime you're gonna open OFM, this one will be permanent. This will contain category, the match, well list. There's a lot of filters, and the time will not be enough to talk about this. And also we have the navigation. The navigation will show you the hierarchy of your project, starting from the smallest entity you have, which is the completion, and then the wellbore, the current water, pool, supervisor, whatever. And the largest entity may be the field you are dealing with, and you can change the layout here. This is my favorite, to have them all in place. This one block in your vision, you just can move it, make it small. Okay, so let's go back to our main subject, which is forecasting. Let me show you the legacy forecast. This is what I meant when I said the scenario and scenario manager schedules. Once you open your forecast, this will appear. But in the new analysis dashboard, this will not be included inside the forecast. It will be in a separate place. It will be here in the template. Okay, so let's depend on the new forecast, the new analysis dashboard. Here you can set your templates. This is the default. Once you open it and you just starting using OFM and forecasting, you will see the default scenario. You can copy it and create a new one. Okay, I already copied it here. Let me rename it. Let's call it ARPS 2. Okay. And as I mentioned here, you have to determine your phase. These are your phases, or you can make your forecasting based on ratio, like water cut, oil cut, water oil ratio, GOR, etc. And from here, you can pick your solution. We are doing it with ARPS. My oil rate, which is oil rate, and then cumulative. Let's go to cumulative oil prediction. So I'm so sorry, my eyes are not helping. Okay. The analysis rate cum. We're gonna keep it rate time. From here, you can pick your best or fit type. We have the best fit, which is in here. Here you're gonna depend on all of them generating your best fit, or you can just like specify it for exponential or hyperbolic, harmonic. I'm just gonna keep it best fit by all of them. Also, keep the general settings for optimizing the p-value, DI, and so on. And then we're going to add schedule, your start time. I'm gonna keep it from month from end, and also the start rate. Okay, keep it historical rate. Here's the end time. After what time the forecast will be ended. Here's 1020 months, 10 years. And your end rate, keep it rate. At this rate of prediction, your forecast will be ended. This is a new feature in OFM forecasting, which is end based on. Based on what? You can end your forecasting based on phase, such as gas, water, uh, the other ratios also. I'm not going to use it here. But this is a very powerful feature because even if you don't have a forecast case for these phases, you're not saving a forecast case of these phases, you're still able to use it and end your forecast once you pick one of these phases. Okay, I'm gonna leave the general settings for this one. And also let me specify for gas. Just gonna pick the rates. Calendar gas. Okay. The same settings. Also, this is pick from fit here and keep the same settings. You can save it, or once you move to another template, it will tell you if you want to save or not. So it won't skip this step. Yes. Once you open forecasting, the forecast will be automatically generated here because you already set your template. All what is needed here, you come here to pick your case. We have case 1. And then you have to pick your phase, the phase you are making your forecast for. If it was oil, gas, water. For us, in this case, I just specified my variables for oil and gas. And in entities, you can pick your entity. I'm going to leave it on the current. And of course, the template, let's use ARPS. These are the templates that I already have created. And just click finish, and your forecasting will be done. Click finish here. As I told you, you can move it. It was blocking the vision. These are the limits, the 2 green line here, the dotted line. And this is your data. And this is your forecasting line. You can just adjust it. And in this part of adjusting your forecasting curve, there's a lot of things you have to be careful about. You need to pick a very representing and stable period of data because you can see here there's a lot of data. And once you modify your forecasting line, it will give you a different value of ultimate recovery, the EUR. Whenever you are moving your forecasting line, it will give you a different result. So you need to pick a very stable and continuous data, and you can remove the outliers. There's a lot of tools used in OFM to clean up your data. For example, you can just pick right-click and you can use, for example, use lasso to exclude points. If I see that these points are affecting my forecasting, I can remove them. Okay, they are fading now. So these points will not affect my forecasting. Also here, just like outliers, And just by drawing a circle, okay, now it's faded. Also, in 2023, there is an additional feature, which is the digitized point. This will be points for forecasting that is defined by the user himself. You will draw different points and then right-click again, tell OFM you are done with your points, and look, here is your line for forecasting. Okay. This is ARPS2 that I've just created. Oil and gas. In case we are picking more than just one case. Uh, one of the other features, if you are showing, just let me delete this one. I don't need it. Okay. Now, we already created templates for two different phases. I created a template for oil and I created a template for gas. You can see them once you pick them together. You can see them in a different graphs, but you can activate them and like join. It will be joining the same graph here. Once you zoom in, you can use this one to reset your zooming. You can hide oil by using this icon and focusing on, no, I hide the gas now and focusing on oil. Okay, now I'm showing them both. Okay, this is for forecasting. Once you say, this is a saved forecast here that I already have. Look, once you adjust your forecasting line, the schedule will give you a different or a new result. Remove this one. This is a not stable or not representative period of data. Look, my forecasting schedule is moving. Oh, little princess is shaking. Oh, okay. Sorry. Let me adjust this point too. Okay. Here you can see your result of forecasting. The EOR will be changing each time you are moving your forecasting line. This is the EOR. This is the p-value. This is the parameters you already set in your template. And also you will have the summary. And we have the datasheet. What are those three things telling me? Okay. In this schedule, this will show you the parameters that are associated with your working forecast, not the saved one. No, the working that you are working on it right now. And it will be separated from the schedule by the historical data here. And this is your schedule. The summary here will show you, or the summary tab will provide the parameters that you have to the database. And the last thing we have in here is the data sheet. The data sheet will provide you just like a type of view that is similar to separate sheet. Okay. And this one, just like right click and you can export it to Excel, you can export it to Word also. And you can see here this little icon. This is called column chooser. You can pick your columns. Which one you want to see, which one you don't want to see. Okay. I will activate it again. I want them all. Okay. So this is a saved forecast. And once you are convinced with your forecasting, you can save it to database. or you can reset it here. Reset your decline curve result to the original result. Now it's reset. Before I moved this one, the forecast time. Or simply I can save it. Let me make some changes. And then save it. Okay, it will be saved here. Now I have a new forecast case for the gas, for oil here. You will be able to forecast the different entities. It's not just the one well or a set of completions. You can make your forecasting for the pole, for um, well bore, for reservoir. So let me here clear the filter. Oh yeah, there's something I'm sorry, I forget to mention. Here you can clear your filter. There's a lot of this icon. You can find it here in the ribbon. You can find it here in the in the home tab. Also, you can find it in filter. Once you move to filter, just a minute. Yes, you can group your entities with the summation, the blue icon for summation here. And you can clear your filter from here. And once you group it, you can see the selected completion here in this ribbon. Let me clear it again. Okay, now none of them are chosen. And let me go back to show you that we can make the forecasting for different wells and different completion at a time. I'm holding the Control key, and I'm just gonna pick different wells and completions. For example, this. Oh, sorry. Yeah. This one too. Okay. Now I just picked the different completions. There is no connection between these completions. For example, where's my browser? Guys, you still see my screen, right?
No, actually.
Okay. Just a minute. Okay, I'll stop sharing and share again.
Okay.
Yeah. Okay, it seems my OFM crashed. Just a minute. Please let know once you can see the screen.
Yeah, it's live.
Yeah, it did. It crashed.
It's okay.
Oh, let's be more careful. Yeah. We were showing. Let's come back here. I'm showing with ARPS2 the latest template. We will be showing oil and gas cases. Gonna keep it for the current and just finish it. Okay. We don't need ARPS. No. But I wanted to show you that you can pick different completions at one time just by holding your cursor key and picking different completions. And then the forecasting will be generated in both cases for oil, in this case, for all of these completions that I selected. Here you can show completions selected are 5. This is forecasting for oil, and this is forecasting for gas. And you can, once you are convinced with your forecast, let's make some changes here. This a little. Okay, you can save it. This is for gas, and it will tell you to rename. Let's say let's say rows, for example, 5. You can find it here in the forecast. Look, it will be saved under this wells 5. This case is gas. Let me save the oil case. Look, it's showing for the same case because it's for the same 5 wells. Now it's saved. So don't limit yourself. You can make the forecast for different entities, completion, wellbore, whatever entity you want to make a forecast for, go ahead. Okay, so let's go back to our template. Let me clear the filter. Okay. Then group my completions. Right-click, there is another choice here. You can edit your template for case 1 for oil, and you can save the forecast. I want to edit my template. You don't have to go to the analysis dashboard again and edit it. Just like a right-click, click a group of a button, and I'm gonna show you that we can use the end based on property. Let's say I want to make this forecast end by gas. Okay. Once you add this feature, you can see that your forecast for oil will be connected completely with your forecast for gas. Look, once you modify or you end or limit your forecast of for the gas case, the oil forecast will be moving and will be ended just depending on the gas case. They are connected. Okay, I mentioned that you can do it even if you don't have a phase forecast saved. For gas now we have. Just let's make it for water. Okay. Let's maybe get here. I don't have a water case. It will just ask you for these variables. The water rate, can determine it. See the water rate. Oh, this one. And then the cumulative. I think this is the one. Then done. Okay. Phase. Okay. Now, for water is added in ARBS. It should be colored by phase. Okay, no problem. Also, here we are using only ARBS. Let me remove all of these. In case you want to add another template, I already have the power law and the stretched exponential. Okay, let's keep it on oil. Okay, now you can see the forecast with the 3 different methods. This is for the 3 different methods. Let me activate it for power law. This one will combine them in one graph. Let's just keep it separate. Okay. In order to make some selections between them, I'm going to make the coloring based on the forecasting method. So you can see it clearly. Each forecasting method have its own color. This would be more clear. These are the different methods. The exponential, the stretched, and power law. Okay. And for sure, this the plus sign here, you can add any type of forecasting. So you can display them in the same dashboard in case you don't know about this one. Okay. Let's just close this one. It's not needed for now. Okay. Okay, since it's already 6 and 10 minutes, I don't want to take your time for questions. Um, Guys, we have 30 minutes for questions. Do you have any question? Do you want me to show you anything that is we can do in while I'm opening my demo? Please go
Hi,
ahead.
can I ask?
Yeah, sure. Is
Yes,
there any
please.
feature you want to see? Yeah.
Thank you. So thank you for your OFM presentation and experience in OFM. But I ask you, when we have the forecasting, how we can
Mm-hmm.
match the data of our result with the, let's say a case study data, so we can have the history matching, or we can verify that our result is good, or there is a good match between the, let's say, the measured data and the forecast data. I mean about
There is,
matching.
yeah, yeah. Thank you for the question. There is a feature that was added here in OFM 2023 that is called the Forecasts Variance Report. You can find it here in Forecast Manager. Pick your case and then run it. This should show you the variance between your original data and your forecasted data. And
Uh,
also, Taiba, if you have anything to add on this answer, please go ahead.
Thank you so much, Fatma. I think you have really addressed this question very well, because this is basically the latest edition, and it was intended for the to show the discrepancy or the variance between the forecasted and the actual measurement. We have also the let's say the ability to visualize, the data, so you can have a look at the trend and you can see how your forecasting matches your actual data. But this one here, the utility that Fatima just showed, is actually the latest edition. Um, and yes, basically it serves this purpose.
Thank
Yeah,
you.
also this will act like a separate sheet, so it will show you the difference in Excel type of a view.
Okay, thank you for your answer, and I'm happy with your answer. But please, can you just show me what's the icon that you use in the newest edition of OFM? Which icon? I mean,
Oh, yeah, sure.
yes. Uh, yeah.
Forecast Manager and the Analysis Dashboard.
Okay.
This is
Okay.
containing the report. This one will contain your templates. Here you
Yes.
will set the templates and set your phase, um, your variables, and everything. And you can open your templates here in the forecasts. So
Hmm.
please, I want you to pay attention here. In forecasts, we just open the templates that already created here down. So in the lower section, you have here it's the reports and the forecast manager. And in forecast templates, let me open it again. Here, look. Here you will set your method, you will set your phase, your schedule, and the schedule details from which time you are going to start your forecasting, to which time you're going to end it, and the ending rate and the details of it. And in this case, for the historical data, this is your phase you are making your forecast for. This is your variables to which they are referencing, which is mostly CD, CalDay rate for oil, for gas, or any variable, any phase, sorry. And from here, you can pick the best fit or which type of curve you want to pick, and OFM will generate it once you open the forecast. Let me go again. So let's say here you already set it your template, and it will only remind you if you want to save it or not. I want to save this one. And you come here to open your template that you created here. Open forecast, and your forecast will be generated automatically. Hope this was clear. And here's the report. Did I answer your question, Mohammed?
Yes. Thank you.
Yeah.
So thank you
please,
for
go
your
ahead.
answer. We have Hussein Shakir in the chat box. He said, how does OFM address scalability and performance issues when handling large data sets and or complex reservoir models?
First of all, in case you have a large data set, there's also new addition in the 2023 version. What is called the boxplot. Let me open boxplot. This one is used to QC data. Sorry. I already have one here. This is used for QCing the large data sets, more than 20 entities. For example, let's say, not completions, let's say flow station. So these are two, that should be the boxplot for flow stations. So you can do your quality checks for data on all of them before dealing with it. And in case of dealing with a large data set, sorry, what was the question? Can you please come again? Repeat your question.
Fatima, the question is in the comment section. He
Okay.
says, how does OFM address scalability and performance issues when handling large data sets or complex reservoir models? So basically, you have the option to actually, intervene in the way OFM deals with the database. For example, the number of SQL queries. How do you want OFM to retrieve the data? If you want to limit the data that OFM deals with, which is something that we actually use the permanent filters, which are the project filters for. This is specifically, or let's say one of the big reasons why this was developed is to limit the amount of data that OFM handles in a single run. So instead of having to recall the data from the database of all the wells, of all fields that you have in the project, you can filter and use the permanent filter to see only the wells that you're concerned with. This way you will reduce the runtime and the amount of data basically that OFM has to deal with. So this helps you have a very smooth way of using the software. So there's a lot of flexibility, and you have the ability to choose how you want to deal and how much you want to deal with the database. So that's how you can optimize your the software performance basically when dealing with large data.
Thank you for your answer. We also have two individuals raising their hands, like Mesa. Mesa, please go ahead. Mesa, could you please confirm if you hearing me? Okay, we have another one raising their hands. Please go ahead.
Hello, hi. Can I ask a question?
Sure, please go ahead.
Okay. So when it comes to forecasting reserves and reserve estimation, typically you report constrained reserves. So is there a way to basically for all FEM and Pipesym to work together to implement surface constraints in your forecast?
So Fatma, I will take this question. The answer is yes. We have a number of ways to integrate the software. This can be done, for example, through a Python script. This can be done through IM software, which is integrated asset modeler. In any case, yes, there are a number of ways where you can connect the two softwares and perform such operations. Yes,
Okay, thank you so much.
thank you.
If anyone wants to ask something, please do by write your question down in the chat box, or you may raise your hand and speak up. So I think that's all, and we don't have more questions. I would like to thank you so much, Fatma and Engineer Taiba, for your presentation and the time to being here with us. Much appreciated. I would like specifically to thank all the 5 speakers throughout the SLB webinar series, and specifically Engineer Taiba for her efforts in making this collaboration true. Much appreciated. Thank you so much.
Hello, Mohammed. You're most welcome. It was a pleasure to present and help you guys. I want to thank you and the attendees for their time and attention. And please don't hesitate if you have any question.
Thank you so much, Mohammed, for the opportunity, actually. And we will always be happy to support you and to support the professionals, the undergraduates who are the future engineers in the industry, in case any support is needed.
That's very, very nice of you. Thank you so much.